Okay, picture this. We have a map of the entire universe, one that's guided us for decades. But what if we started finding clues that just aren't on the map? What if the map itself is wrong? That's the exact question we're diving into today. A cosmic detective story that could rewrite everything we thought we knew.
So yeah, this is the big one. Is our map of the universe wrong? This is the monumental question facing astronomers right now. And it's a question that challenges the very foundations of cosmology. I mean, everything from the Big Bang to the galaxies we see today.
Now, to understand any mystery, a good detective knows you have to start with the established facts. For us, that means looking at the map we've been using for almost a century, the Standard Model of Cosmology.
And look, this map has been incredibly successful, and for good reason. It explains the Big Bang, the expansion of the universe, even really weird stuff like dark matter and dark energy. You can think of it as this super detailed atlas that's become the bedrock of modern astronomy. But, even the best maps can have uncharted territories.
And that's what's happening. Our most powerful telescopes have started sending back postcards from those uncharted territories. And the clues they're revealing are, well, they're puzzling. We're finding things that simply shouldn't be there, and they're creating some serious cracks in our beautiful map.
One of the first major clues has to do with things called quasars. So what are they? Basically, they're like lighthouses in the deep universe, these incredibly bright beacons powered by monster black holes. And because they're so bright, they are absolutely crucial for us to study cosmic history.
And this is where the first clue drops. Astronomers found Ponumuena, a black hole from the dawn of time that weighs 1.5 billion times more than our Sun. Now, according to our map, a black hole this massive just didn't have enough time to grow that big so early on. It's like finding a skyscraper in a village that was founded yesterday. It makes no sense.
But Ponumuena wasn't just a one-off. Pretty soon, the amazing James Webb Space Telescope started spotting something else. A whole population of mysterious objects that astronomers nicknamed little red dots.
And these aren't just any dots. We're seeing them way back when the universe was just a toddler. They all seem to be powered by supermassive black holes, and there are way more of them than our models ever predicted. On top of that, the light they give off, this unique fingerprint of infrared and X-ray signals, it's just strange. It doesn't match a typical quasar at all.
Yeah, the heart of the problem is captured perfectly by astrophysicist Jorit Mathie here. He basically says scientists are struggling to even figure out what they're looking at. The clues are right there in front of us, but they're written in a language we don't understand yet.
So, we've got these deep cosmic mysteries piling up. But here's the thing. At the exact same time, our ability to investigate them is just exploding. And this isn't only in astronomy. Science across the board is in total overdrive.
I mean, just take 2023. We had AI discovering new medicines, surgeons pulling off the world's first whole-eye transplant, and yeah, even in astronomy, we saw the afterglow of planets smashing into each other for the first time. The point is, our tools for discovery in every field are getting unbelievably powerful. And it's that power that's letting us find these cracks in our cosmic map.
So this combination, these profound mysteries and these powerful new tools, it's led to a huge moment in cosmology. The clues have become so important that the world's cosmic detectives are, you could say, officially assembling.
Scientists have a very specific name for this kind of problem: observational tensions. It's a fancy way of saying that what our map says should be there and what our telescopes are actually seeing are in a direct conflict. And that is a very big deal.
And the conflict couldn't be more clear. Our map predicts a universe where giant black holes take a really long time to form, but our telescopes are showing us they were there right from the beginning. Our map predicts that super powerful quasars should be rare in the early days, yet we're finding these little red dots all over the place. The evidence is flying in the face of the theory. So the response from the scientific community has been massive. How massive? Well, get this. More than 500 scientists from all around the world came together to co-author a single, unified paper. That's not just another research paper, that's a global mobilization.
They called it the CosmoVerse White Paper. And it's basically a strategic plan, a roadmap for how we're going to solve these tensions. It's the detectives laying out their entire investigation for everyone to see.
So where does all this leave us? We're at the beginning of a seriously thrilling new chapter in our quest to understand the universe. The hunt is on for answers that might lie completely beyond our current map.
And their mission is crystal clear. First, recheck everything. Go back through all the data, see if we maybe made a mistake in our observations or analysis, but and this is the really exciting part, they're also going to explore fundamentally new physics. The idea that maybe our map isn't just missing a few details,
Maybe it needs to be completely redrawn.
And that's really the key thing to take away from all this. What we're witnessing is the scientific process at its absolute best. It's not about having a book full of answers. It's about bravely facing the contradictions, asking the really hard questions, and launching a bold, collaborative investigation to find the truth wherever it might lead.
So, as we stand here with a map that might be outdated and a universe that's full of all these surprising new clues, the ultimate question isn't just whether our map is wrong, it's what entirely new cosmos are we going to discover by trying to fix it?